Okay, so this is the last video on kinematics, and we're talking about acceleration. Now, acceleration is the rate of change of the velocity. Okay, the average acceleration equals the change in velocity over the change in time, and the other thing we need to worry about is instantaneous acceleration, which is the first derivative of velocity, or it's the second derivative of displacement. Okay, so it's the first derivative of velocity, the rate of change of velocity. But because velocity is the rate of change of displacement, it's the second derivative of displacement. Okay, so just make sure you understand that. So first derivative of v, or it's the second derivative of x. Okay, copy that, come across. Okay, just so you understand the units. So because acceleration is how velocity is changing, velocity is meters per second, and how it changes is relative to time. So meters per second is called meters per second squared, which can be written as ms minus 2, or kilometers per hour squared, which is kmh minus 2, etc. But the reason it's second squared is because it's meters per second, so it's meters per second squared. Come across when you're ready. Okay, so just some additional notes. If the acceleration is 0, the particle is moving with constant velocity, but the particle could also be stationary. Now, the way of thinking that is, if you're traveling with your parents, or you're driving yourself, and you're traveling with constant velocity, 60 kilometers per hour down Northbourne Avenue, and hopefully you're not driving, because if you close your eyes, your body can't tell if you're moving with constant velocity. If the acceleration is 0, you can't tell whether you're moving with constant velocity or stationary. So next time you're in a car and you close your eyes and you can't feel anything, you don't know if you're moving with velocity or you're stationary. Now, the only other couple of things you have to mention, the direction of motion and the acceleration doesn't have to be the same thing. So for instance, if I throw a ball upwards, so the ball's going up, so motion is up, acceleration is due to gravity, and it's going down. So motion and acceleration don't have to be the same direction. But if velocity and acceleration are both positive, then you can say the particle is speeding up. Okay, we've had that before, or actually you're going to do that on motion graphs later on. Okay, come across when you're ready. Okay, so we've got one example. A particle moves in a straight line, so this position x relative to O, the central position, is given by x equals blah blah blah, t is greater than or equal to 0. So find the particle's initial position, its initial velocity, and its initial acceleration, and find when the particle is at rest. So at rest means v equals 0, and determine its position and acceleration at this time. Okay, so x equals t cubed minus 6t squared plus 5. So straight away we know that the velocity is the derivative, so 3t squared minus 12t, and then 5 disappears. And we might as well write down acceleration because we need it. So that's 6t minus 12. So there are three formulas, not four formulas. So part A, at t equals 0, because that's what initial means. Initial means t equals 0. X is at 5, the number at the back. What's the units? Units are centimeters. The velocity, there is no number, so the velocity is 0 per centimeter squared, and the acceleration is the number at the back, so it's minus 12, so that's centimeters per second squared. So that's the initial position, velocity, acceleration. Okay, part B, at rest v equals 0. So we look at our v formula. So 3t squared minus 12t equals 0. It's a quadratic, so we have to factorize. 3t minus 4 equals 0. And so there are two times. That answer is t equals 0, and that answer is t equals 4. So when is the particle at rest? At 2 times 0 and 4. Okay, and what's its position? So at t equals 0, well, we've already done that. So x equals 5, a equals minus 12, and at t equals 4, we're going to put 4 into that formula, and so I'll save you time. The answer is minus 27. and the acceleration is 6 times 4 minus 12 equals positive 12. Okay, so don't forget to put the units. But that's it. That's the last video on this topic. Okay, bye.